Okay, to determine if an input value is a member of the domain, as in it would be included in there, we have to put this number into our function like we're evaluating it. So if they say is 1 in the domain, we would put this in here where x is at, like we're evaluating this. Okay, I would just use your calculator to simplify this. But here we would get 1 over -2. So -1/2, that's a value, that's an output value that is definitely included in our domain. However, if you look at this one, if I plug in 3 here, we get 1 over 0. If you type this in your calculator, 1 divided by 0, it's always going to say like domain error or some kind of error there. That's because this is actually not included in our domain. I actually do want to show you what this would look like on a graph. You actually can't use this calculator in class, but I did pull this up here because I wanted to show you what this looks like. So if I put this in my calculator, this is what this graph looks like. So you can see over here at 3, I can't draw right there, sorry, but you can see at the x value 3, those lines actually both curve away from that value at 3. So it never actually is at 3 because in math you cannot divide by 0. Now, if they're asking you to find domain and range values, domain is always how far left and right it goes. This approaches negative infinity to the left and positive infinity to the right. So if it doesn't end to the left or right, that's what you're going to write. If it does end at a value, you're going to write that value. Range is how far up and down it goes. And up would be infinity, down would be negative infinity. So you have to know that if there's no ending there, that's what you would write there. So the way I like to do this is if you can write a box, then write a box because it's going to help you decide what those values actually are. So for example, on this first one, this one goes to here on the left, it goes here on the bottom, and I can't draw a box on this right hand side because that arrow is going right forever. And I can't draw a box on the, or a line on the top because that line is going up forever. So we know over here, this is going to go to infinity because I can't draw a line there. And this is also going to go to infinity on the top because I can't draw a line there either. Now our bottom value, the lowest this graph goes is -4. And the farthest left this graph goes is -3. Okay. When I am writing these, I'm going to write them in inequality notation. Less than or greater than symbols means that it is an open dot there. If it has less than or equal to, greater than or equal to, or it could be equal to, this is a closed dot or a line. So it's actually included, it's equal to at that space. But if you look at this dot at -3, this is an open dot. That's because that line goes towards that value, but it never actually is -3. So we want to know that it goes all the way to it, but we also want to know that it never actually does equal -3. So if I look at my domain, the farthest left it went is -3, and the farthest right it went is to infinity because it never stops. Infinity and negative infinity are never included because I can't actually ever reach infinity or negative infinity. They go forever. I couldn't ever actually reach them. So we say that they're not equal to because we can't get there. So I'm going to put x in the middle because domain refers to x. These are really good notes right here to take because these are kind of the core pieces of what this is about. Range is y. Okay, -3 was an open dot, so it's not equal to. So we're saying we go from -3 to infinity, and infinity is also not equal to because we can't reach infinity. How farthest down this went is -4, and this is a line here. A line means it's included, so I'm going to go -4, and it's included. Range is y, And the farthest up it went is infinity, which is never included. See how, like, if you remember from back from elementary math, the alligator mouth thing, I'm making it open to the right every time. If you just follow this structure every single time and always have it open to the right and always go from left to right, down to up, then you're always going to get this right. If you start switching directions, sometimes I see people make mistakes on this. If you look at this next one, I actually cannot draw a box around this. It goes left forever. It goes up forever. It goes down forever. It's going to keep going right forever. So I actually cannot draw a box around this. So that means all of these are negative infinities to infinity. So this goes left forever. This goes right forever. This goes down forever. This goes up forever. So we have negative infinity, not included, to infinity. Negative infinity, not included, to infinity. A couple of key points here. Make sure when you do range, you do y. When you do domain, you do x, because domain is x, range is y. Okay, on this next one, I can definitely draw a line on this side. I know it's not a very great line. And I can definitely draw a line on the bottom, but I can't really draw a line going left or going up. You might be able to, in some cases, assume that this approaches an asymptote, but just for this case, we're going to assume that this is all there is, and it's going left and up forever. Okay, so this is going left forever, so it goes to negative infinity. My line over here is at 3. At the bottom, it's at 1. Okay, so 1. And it goes up forever, which is infinity. So we have negative infinity to 3 for the domain. We have 1 to infinity for the range. Now we just have to decide, we have x, we have y. At 1, this is not included because it's an open dot. At negative infinity, also not included because negative infinity is never included. We can't reach that. At 3, it's also not included because it's an open dot. At infinity, it's also not included. It's an open, or it's going to infinity. So we're going to make that not equal to underneath there. Okay, you go ahead and pause the video, try these 3, make sure you give it your best, make sure you actually pause the video and try these 3, and then when you come back, I'll go through the answers. Okay, so I can draw a pretty good box around this first one. This goes up this high, down this low, left this far, right this far. So it goes left to negative 3. It goes right to 4. It goes down to negative 1. And it goes up to 4. Okay? Both of these endpoints are open dots. That means all of these are going to be not included. So we go left from negative 3 to 4. And that's my x value. And they're open dots. We go down to negative 1, up to 4, which is y for the range, and they're not included, they're open dots, they're not equal to. This next one, we can draw a pretty solid box around this too. This goes left this far, right this far, down this far, up this far. Okay, so it's all contained within this box. So it goes down to negative 5. It goes up to 2. It goes left to negative 3. It goes right to 2. Down here at the bottom, this is an open dot, but over here, this is a closed dot, and at the top, it's a line. So we do have to pay attention to that. So at negative 3, it's a closed dot. So that's going to be an equal to. Over here at 2, this is an open dot, so we need not equal to, and domain is x. Down here at negative 5, it's an open dot, so it's not included. And up here at 2, it's a line, so that is included. Okay, Now this one, I can draw this bottom line, but it's going to go left forever, it's going to go right forever, and it's going to go up forever. So we got to keep that in mind. So it goes left to negative infinity. It goes right to infinity, which is x, and they never have an equal to. This goes down to 0, and this is a solid line here. It's not an open dot. The only time you're going to do not equal to is infinity, negative infinity, open dot. It's none of those. So it goes to 0, and it's going to have an equal to. It goes to infinity, which is never equal to. And that's it.